5 minutes.
Stay on deck for a bit. All right, fine, Doctor.
Beginning to get light.
Quite a bit.
Hi, Jerry. Worried about Mike?
Well, it's too late to worry about that now.
The Shot Island is about over in there?
That's right. It's generally north and west of us. For the past half hour, the ship has been headed directly toward the Shot Island, and will continue to do so until shot time.
You know, there's one thing I can't quite put together. That's this business of success or failure. I've heard there's a 50% chance of its failing. Now, this low margin of success wasn't true on the other shots, was it?
No, it wasn't. Let me try out the Admiral's chair.
Sure.
Up until this operation, that is, from about 1945 through 1951, the chance of failure has never been more than about 10%. In Crossroads, Sandstone, and Greenhouse, we had great confidence in the operation succeeding. We recognized the change in philosophy, however, when Dr. Bradbury spoke to a group of us at Los Alamos in 1951.
Gentlemen, up to now, the laboratory has had sufficient time to compile information and revise weapon design before a field test of a weapon. As of now, the situation has changed. We must take risks. Calculated risks, it is true, but risks nevertheless. According to the presidential directive, we must ascertain if a hydrogen bomb is feasible and do this in the highest possible speed. We must ascertain if such a bomb is feasible, if we can, in 1952. Here is what I think we must do. We must set up a special staff under Dr. Marshall Holloway, reporting directly to my office. He will receive from the theoretical division the theoretical designs of such a system, have them fabricated and shipped to Eniwetok. There, they will be taken by Dr. Graves and J Division and tested. It must be recognized that we're taking great chances, a great gamble, but a gamble, while there's a possibility of failure, nevertheless there's a possibility of great gains. Eniwetok will become our theoretical laboratory rather than a proving ground.
And that's the way it is today. We're taking a gamble.
I see that now. But then the uneasy state of the world puts everything on a gambling basis, I guess.
Yes, but not as much of a gamble as you might think. Take that man over there. He and his company have put a great deal of thought into the engineering and design of Mike. Well, see you later.
So long, Doctor, and thanks a lot. I couldn't help coming back to the control room for another look. They tell me everything's going along without a hitch. I've been taking a closer look at the cryogenic screens there. You know, there's a lot to this low temperature work. In a good many respects, it's the most outstanding problem of the entire operation. And as soon as Bob Gibney can break away, we'll talk about some of these problems. But this I know. A lot of heads have been scratched trying to figure out some way to work with various gases which have to be brought down to a liquid state. Oh, Bob, I've been browsing through this subject of low-temperature physics.
That's quite a subject.
It sure is.
The general problems connected with very low-temperature operation had been met on the George shot of Greenhouse. The amount of thermonuclear fuel required for Mike shot is considerable. Do you remember the buildings in the south end of Perry, near the airstrip?
Yes, I do, Bob.
Well, that's the liquefaction plant. The original plant was established during Greenhouse. Because of the difficulties in transporting, the decision was made to produce liquid hydrogen at Eniwetok rather than in the States. But for Ivy, it had to be expanded considerably. The capacity of the original hydrogen plant was doubled for the production of liquid deuterium, and a new plant was built for the production of hydrogen with a capacity 4 times the old Greenhouse model. The small nitrogen plant was expanded 8 times its original size. For Operation Ivy, the Perry Island plant operated continuously for 3 months to produce the necessary low-temperature liquids needed in the experiment. But of course you don't put a material so difficult to make and so difficult to keep in milk bottles. You use special containers called dewars, which are simply outsized thermos bottles. Months ago, these dewars were made in Massachusetts by the Cambridge Corporation and driven out to Boulder, Colorado for testing. Each dewer is mounted on its own truck with its own refrigeration plant and generator. Against the picturesque background of the Flatiron Range of the Colorado Rockies, these dewars were filled with liquid hydrogen at the cryogenics lab of the National Bureau of Standards. This plant, set in an unpopulated area, is the largest source of liquid hydrogen today, and hydrogen is essential for a practical shakedown test.
The climax for these dewars came out here at Eniwetok when they were actually used for the job intended, transport.
Since production of thermonuclear fuels might be needed on future tests at Eniwetok, it was thought best to put the liquefaction plant on Parry Island instead of on the Shot Island, where it probably would be destroyed. But this meant a satisfactory means of transporting liquid hydrogen from Parry to the Shot Island. This type of exaggerated thermos bottle mounted on wheels was the answer. A dewar is constructed to isolate the contents of the dewar from the outside temperature, so no heat can leak in. Contained within the boilerplate outer shell is an inner shell made of stainless steel with a vacuum in between. This is the container which holds the liquid hydrogen. A radiation shield made of copper surrounds the bottom half of the inner shell. There are two bottoms to the radiation shield, and in the space between them, there is room for liquid nitrogen. The purpose of the radiation shield is to provide a barrier to the flow of heat. The heat which does leak in boils away the nitrogen first, thus protecting the liquid hydrogen. But even with all these precautions, another source of heat still occurs in the inner shell. This is mainly due to a special property of hydrogen. The molecules of hydrogen, as a gas, exist mainly in a state called the ortho. At first, when the gas is liquefied, the molecules stay in their original state. However, within a period of some 2 weeks, the molecules rearrange themselves into a state called the para. This is a natural phenomenon which always occurs. In this transfer, heat is given off, actually sufficient heat to boil off 2/3 of the liquid hydrogen. To take care of this excess heat, a special refrigerator has coils located in the inner shell. The refrigeration plant, which supplies these coils, does a remarkable job, for its coolant approaches absolute zero. Absolute zero, that unimaginably cold zone where everything stops. All life, all molecular motion. Minus 459 degrees Fahrenheit. A little above this fantastic figure, hydrogen becomes a liquid at minus 423 degrees Fahrenheit. This is the temperature to be maintained in the dewar, only 36 degrees away from the bottom, absolute zero. The helium refrigerant used can affect a temperature sufficiently low to cause the gaseous hydrogen boiling off to return to a liquid state.
Well, I went into more detail on the cryogenics end of this project than I intended.
Well, so far, we've pieced together quite a bit of this operation. I don't believe you've ever had a good look at our key test islands. The test islands for Mike are located at the top, or the northern sector, of Eniwetok Atoll, some 25 miles from Parry and Eniwetok, the two base islands of this atoll proving grounds. There are 3 main islands making up the test site. These are Allujalab, Teeter, and Bogon. Early in the game, these islands were linked together by causeways. The old business of men and machines digging and piling up coral sand. These connecting roads were built to make it easy to get from island to island, and also to act as land platforms for some of the instrumentation. A sizable camp was set up on Teeter. First, it housed construction people, and later served as an advanced base for scientists working on the Shot Island. In the early months, Allujalab was just another small, naked island of the atoll. But by midsummer, it began to look like the thing it was selected for, a Shot Island. Actually, the cab, so called because it houses the weapon, is not a cab at all, but a building set flush to the ground. It has all the earmarks of a common workshed, but in reality, it's a laboratory building set on a Pacific atoll.
How do we stand at Kwajalein?
Hey, Charlie.
Then they're all on the way except for the third and fourth sampler elements? Right. Are you picking them up on the scopes as they come into the area? Right. Yeah, well, from here in, let us have immediate notification if exact shot positions aren't maintained.
This is Broadway 3.
Yeah, and the helicopters, we expect to order them out in about...
Aerology, which may require to move some of your units.
This, as you have probably gathered, is joint operations. All atomic test operations in the Pacific so far have been run under a joint task force kind of setup. Operation Ivy is using the same organizational structure as Greenhouse. 4 task groups: Scientific, Army, Navy, and Air Force. Members of these groups are here now, sifting and coordinating the many details of this joint operation and passing key information topsides to the command level. The Army is...
Broadway 2. 4 Cape Cod has radar contact skunk.
The Army is the executive agent on this operation, just as the Air Force was on Greenhouse and the Navy on Crossroads before that.